So we're going to talk about the periodic table, and based on the title, I don't want that to happen. Based on the title, you can see that it's sort of a periodic table at a glance. You're not looking to investigate each individual square and every element. We're just going to look at the whole thing overall first. All right. The first thing I need you to understand, and most people do, but it's a good reminder. Columns go up and down. So these are columns. Rows go across. Now, many of you know this, many of you don't, but you have to keep those straight, right? Columns hold buildings up, and you're in a different row when you go to a Patriots game or something. All right, so now that we have that straight, let's start with group number. It's the easiest, and here we go. So a group is actually a column. Sometimes they're also called families, but we're going to go with group numbers 1, 2, 3. So you're getting the pattern here, and it goes all the way out to 18. So you can pause right now and just make sure you number those group numbers 1 to 18. Okay, so now let's move on to group names. You are going to have to memorize these. There's not a lot you have to memorize in here, but those you do have to memorize. And actually, they're easier than you'd think. So let's go and look at these individually. So I turned the periodic table sideways just so it was easier to write. So the first column, or group 1, the name is the alkali metals. And we'll talk about, why they are that later. But the first one is the alkali metals. The second one is the alkaline earth metals. Notice the difference. This is alkaline. This is alkali. This one has 2 words. This one has 3 words. 2 comes before 3. People do get these mixed up sometimes. All right, so get those down and then continue. All right, so we have those down. This one in the middle is called the transition metals. Okay. Great. Now let's keep going on. And we get to rows 13 through 18, and the first one is the boron group, and it just so happens, if you look at a periodic table, that this element right here on the chart is in fact boron. So take a wild guess what this one is. Nitrogen, right? And right here is carbon, and right here is oxygen. You can ignore the stars for right now. They're meaningless at this point. But anyway, the last 2 groups are the halogens, and many people know the last group is the noble gases. So now you have all the group names. All right. Let's move on to the period number. So the period number goes down the side of the periodic table. Some periodic tables have them on there, some don't. But it's a pretty easy pattern to remember. This is period 1, period 2, 3, you get the gist, and it goes down to 7. And the period is basically a row. So in period 1, or row 1, you've got this element right here, which happens to be hydrogen, and you follow it all the way across, and you get to this one over here, which is helium. So in this first row, or period, there's only 2 elements, hydrogen and helium. In period number 2, we have these 2 elements, and then we go across empty space, and then it's all of these. So row 2 doesn't have all this. The same with row 3. You have the first 2, it skips all of this, and then here's the rest of row 3. It's not until you get to row 4, period 4, that you have elements going all the way across. And so what does this mean? Well, it's the number of energy levels in the atoms in those specific rows. So anybody in row 1, and there's only 2 of them, only have 1 energy level. Everybody here has 2, Everybody down here has 5 energy levels, and that's going to be really important in a week or so. But for now, you just need to know that it's the number of energy levels they have. All right. Let's move down here to the valence electrons. All right. So number of valence electrons. Oops, I got ahead of myself. All right. So valence electrons are the electrons in the outermost s and p orbitals. Well, we haven't talked about s and p orbitals yet. At least I don't think we have. So you can just put that aside for a moment. You know, have it here, but we'll talk more about what that is. And this also has a fairly easy pattern to remember. So all the elements in column 1 or family 1 have 1 valence electron. Everybody in the alkaline earth metals has 2. And here's the tricky part. Here's the part where people forget. All of the transition metals we skip. The reason we skip them is because they have a more complex structure and they have different orbitals, and so we're just going to skip those for now. None of the reactions we look at are going to have transition metals in them anyway. So 1 in alkaline metals, 2 in alkaline earth metals. We skip the transition metals. We get over here to the boron group. Everybody in that group has 3 valence electrons, 4, and you can probably predict the rest of them. 5, 6, 7, and 8. And 8 is a meaningful number, and we'll talk more about that in class. However, I want you to add this little thing to your periodic table at a glance, because helium only has 1 energy level. It can actually it doesn't have 8 valence electrons. It actually has 2. And we'll talk more about that in class, and you'll get it. Don't worry about it. So those are the valence electrons. Those are going to be the most important thing when we start talking about chemicals bonding with each other and that kind of thing. All right, so we have a couple more things to do, and then we're done. The first thing, there's this sort of landmark, if you will, in the periodic table, and it's a zigzag line over on the right. So if you start right here, okay, so it's these 2 in the boron group, so right between the top 2 of the boron group, you're going to put in this zigzag line. And that's a landmark because touching the line on the right side, we have metalloids. Okay, so all of those are metalloids. And you can look up online what the properties of metalloids. Now, it would also make sense that metalloids would be along the bottom side or the left side of the line, which they are for the most part. This one right here is not a metalloid, although if we look at the pattern, it looks like it should be, but it's not. So that one, don't color your metalloid color. All right, so those are metalloids. What they do in that zigzag line is separates the metals from the non-metals. So let's choose, I chose blue for my metals. And so now we're going to put in all the metals. Now, if you look over here, it says alkaline metals, alkaline earth metals, transition metals. So where are the metals? They're all on this side. All right, so that should never be a point of confusion. All right, so notice I skipped this one. Okay, then that's a hydrogen. So I didn't put in any metals until period 2 or row 2. So I'm going to keep going. There's row 3. Oh, so that thing that, and according to the pattern, should be a metalloid is actually a metal. And we'll just fill these in. Now, you don't have to fill in each individual square with a square at all. You can just shade the whole thing in, or you can even use a pattern if you want. Either way, but don't feel like you have to do that. It's just easier on the computer. And so we have all, or most of row 5, much of row 6, and a lot of row 7. All right, so those are all the metals. And if you look in here, you'll see there are, it's gold and silver and platinum and tin and zinc. So all of those are in here. And so you should recognize those as metals. All right, the last one are the non-metals. And those, in the first row, both of those are nonmetals, right? Because the noble gases are gases, and hydrogen, although it can be in other forms, is generally a gas. And then the nonmetals fill out the rest of the periodic table. All right. So there is our periodic table at a glance. So just by glancing at this, you should be able to tell a group number, figure out a group name, how many energy levels are in a particular atom of a particular element. Along the bottom, how many valence electrons, where the metals, the nonmetals, and the metalloids exist. And we'll practice a lot with this stuff, so do not fear. And we'll talk more about this in class. Thank you very much.